Well, hi there. You see, I'm sitting here on the beach and it's like 80 degrees. It's beautiful out. The sun's in my eyes and got the water lapping on my toes. And I thought to myself, why don't I do a math video for you guys? So, okay, some of that story is true. I'm definitely sitting here. But let's make a math video. Let's go to work on this one. Let's get you ready for this test. All right, Diego has $21.25. He spent some money for one plate at a salad bar and he ate a little bit more. So what's the exact amount of money that he has left, okay? So this looks like it's a subtraction problem. But you know what? I'm going to add these two things together. So I'm going to take the 725 and the 250 and I'm going to put those together. Now, I really don't need to write this down too much because I have the 7 and the 2. Well, you know what? I'm going to do the change first. That'll be easier. Okay, I got the 25 cents and the 50 cents. That's going to bring me up to 75 cents, right? And then I've got the 2 and the 7. So that's $9.75 is what he spent, right? And he has $21.25. So now I'm going to do some subtraction on that one because I'm trying to figure out what he has left. Now the key with the subtraction, remember, you got to line up those decimals. Let's see if I have to do any borrowing. 5 minus 5 is 0. 2 minus 7, I got to do some borrowing. Going to take the 1 and make it a 0. Make that a 5. Make that 2 into a 15. A 15. It's going to be a 12. Okay, 12 minus 7. Okay, which is going to be 5. And I've got 20 minus 9. So that's 11. So 1150. Is that one of my choices? It is. I love when that happens. If it doesn't show up to be 1, it's a little bit like, yikes. Maya's buying bracelets. It's $5.75. And she has $25 to spend. So for this one, we could do $5. We could do $25 and divide it by 725. Strategy I was trying to figure out how many 575s I could make. So I just kind of guessed. I know 2 of them, I'm using estimation. So 2 of them is going to put me about $10. 3 of them gets me up to 15, and 4 of them gets me up to 20. And the 75 cents is like a little bit more in each one. So I thought, well, maybe I'll take 575 and I'll try 4 of them. And let's multiply that out and see what happens. Okay, 575 times 4, so 4 times 5 is 20. 4 times 7 plus 2. 28, okay, got my 30. Okay, 4 times 5 plus the 3 is 23. So $23. All right, and if I do another one, it's going to put me over the amount. So it seems like how many braces can they afford? It's definitely going to be 4 of them. 3, and I can get 1 more, and 5 is way too many. Let's talk about Noah. Noah, he seems to show up in these stories a lot. He's buying school supplies. We got notebooks that cost that, folders that cost that. Okay, oh, he's buying 4, so he wants 4 of those ones, and he wants 6 folders, and he wants 6 of these. We're going to do some estimation. Sweet. Estimation is a really good thing. So 4 350s, right? So 4, 6, 7, 11, 12. So there's maybe 12 with the 50 cents. So maybe 14 about. And $1.25, 6 of those, maybe we'll just say about 6. You know, it's got the 25 cents, so let's make it 7. So we know the estimated total is going to be about 7, and it's like maybe about 21. Let's do that. And notice what I'm doing for an about. It's not an equal sign, it's more of a squiggly one, like almost like you're swimming. So we think it's about that. So now we want to do the exact one. So I got to do some math on this one. So I'm going to take 350, and I want 4 sets of them. That's going to be multiplication. So 4 times 0 is 0. 4 times 5, 20. 4 times 3 plus 2. That's going to bring me to 14. Drop the 0. No, don't drop the 0 down. That is such an adding and subtracting situation. This is multiplication. So how I find that is I count the decimal places. The decimal places is 2, so 1, 2, and there we go. It just happens to be when it falls into place. So be careful on that one. I almost did a boo-boo. So it's $14 on that one. Let's go ahead and work with this other one. $1.25. I need 6 sets of those. Let's see, 6 times 5, 0. The 3 on top. 6 times 2 plus 3. Got the 5, got the 1. 6 times 1 plus the 1 is going to be the 7. And going to count the decimal places. 1, 2. So I got to go 1, 2. $7.50. Let me add those two together. So I've got 14. So I got the 50 cents because that's all alone, right? And the 7 and 14 put me about 21. So where am I at? Find the exact amount. is exactly $21.50, which is really close to my estimate. So he's got 25 bucks to spend. Okay, $25 to spend, and he spent $21.50. That's a subtraction problem. Oh yeah. Get some zeros in there, and we're gonna have to do some borrowing. The 0 wants to borrow from the 0 minus 0 is still 0. 0 minus 5, not enough. So I'm gonna go to the 5, make it a 4, and bring 10 over. 10 minus 5 is 5. 4 minus 1 is 3. 2 minus 2 is 0. Now this is subtraction, so I can just drop the decimal down. $3.50 is my answer. Oh yeah, let's keep going. Oh yeah. If you need a break, go ahead, press pause, go have some gummy worms, and then come back to work. How much does 4 pounds of red apples cost? Well, how much is 1 pound? 1 pound costs $2.15. So I need 4 sets of those. So 215 times 4, multiplication. Multiplication. Let's do it. 4 times 5 is 2. 4 times 1 plus 2, that's going to be 4. 5, that's going to be 6. 2 is 8. Got to count these decimal places so I can get my decimal in the right spot. $8.60. That's reasonable. All right, I need 4 pounds of grannies. So 1 is 172, and I need 4 sets of that. So 4 times 2 is 8. 4 times 7, 28. Got my 4 plus my 2, which is 6. Got my 2 decimal places, so 1, 2, $6.88. Super reasonable. How much more of the 2? So how much more? I'm going to have to subtract these to find out how much more. It's like a comparison. When I'm subtracting, I got to line up the decimal. When I'm multiplying, I do not need to line up the decimal. In fact, I ignore the decimal. Yes, ignoring. And you guys are probably great at ignoring things because I watch my students ignore me all the time. So on multiplication, you guys ignore the decimal, multiply it out, but make sure you count the decimal places and get it back into place. But we're subtracting right now, so let's go to work on this guy. I think that's a 6. It is. 0 minus 8, not enough. Got to borrow. 10 minus 8 is 2. 5 minus 8, not enough. Got to borrow. 15 now. 15 minus 8 is 7. 7 minus 6 is 1. Got to let my decimal just drop into place. $1.72. That's what we have left. Let's keep going. All right, we're adding. So adding is one of those things we line up our decimals. Get all the decimal places squared away. So 8 plus 4 is going to be 12. 3 and the 4. Got the zeros. Okay, that's a good, reasonable answer. Let's go to the next one here. Going to get these decimals lined up because we are adding. I'm going to get a 0 there as a placeholder. Keep track of it. 9 plus 0 is 9. 2 plus 3 is 3. There's 4. Okay. Hey, no carrying over. Nothing. That one's a little bit boring. Let's keep going. Maybe there'll be something exciting here. Okay, what is exciting is I've got some 0 place values. Okay. Oh, this is adding. Okay. So 0 plus 4 is 4. I almost thought I was going to borrow, but that's such a subtraction thing. 0 plus 3 is 3. 6, 7, 8. No, there's no carryover. It's just adding stuff up and lining them up. We can do that. We're good at that. Yeah, we can do that. You know what else we can do? We can do this problem. Ooh, subtraction. Determine which one shows the correct way. All right, so I don't actually have to solve these. I just got to find the rest. Okay, the decimals are not lined up. This can't be it. Decimals are not lined up. This cannot be it. So it's only these two. This one has 0 placeholders, which is nice. This one doesn't, but I'm going to put them in and just check this out. 0 minus 8. And they just put 8 down. Okay, I know what this person did right here. They saw 0 minus 8, but they thought 8 minus 0 is easier, a little more friendly, which is true, but we can't do that. We're doing 0 minus 8. So this guy is out, which leaves us with this one, but let's work this one out. 0 minus 8. Okay, got to borrow. This 0 doesn't have any, so we're coming over to here. So this 4 becomes a 3, and that becomes a 10. Now we have some borrow. So 10 becomes a 9, and this becomes a 10. 10 minus 8 is 2. 9 minus 0 is 9. 3 minus... Oh, we got a bingo. Doop-a-doop-a-doop. Let's move along. Let's check this one out. Ooh, some more subtraction. Okay, we got to be careful on the borrowing. Okay, 8 minus 3 is 5 is good. 7 minus 5 is 2. 5 minus nothing is 5. 0 minus nothing is 1. No borrowing. Snore. Come on, let's get some borrowing going because that just keeps it exciting. 0 minus 2. Okay, I asked for it. I better be able to do this. Okay, 0 minus 2, not enough, so I have to borrow. 3 becomes a 2. 0 becomes a 10. 10 minus 2 is 8. Yep, we're on track. 2 minus 6, not enough. Come over to the 9, becomes an 8. Bring 10 over. So that 10 with that 2 makes that 12. 12 minus 6 is 6. 8 minus 3 is 5. And the 4 minus 0 is 0. Yeah, that's getting interesting. Whoa, look at all these digits. There's so many. We can do it, though. 5 minus 8. No, not enough. Let's borrow from the 9. 9, you become an 8. Bring 10 over, so we have 15. 15 minus 8 is 7. 8 minus 2 is a 6. 6 minus 7. That's getting to the negative numbers, but let's just borrow from the 8. Now we have 16. I got enough. 16 minus 7 is 9. 7 minus 0. 3 minus 0. We got a bingo. Speaking of bingo, let's talk about bananas. Yeah, those don't relate, but that's okay. So we got a store selling bananas and milk and bagels. Let's see, Claire. Oh, Claire, what do you want to do? She's going to buy 4 pounds of bananas. So I need 4 of those. She wants 2 packages of bagels, which is this. Oh, and just a 1 gallon of milk. Okay? So look what she did. She estimated the cost is going to be less than 15. I'm going to pay attention to that, less than. Okay, so 4 pounds of bananas. Okay, so that's like 0.5, right? So 4 sets of that is about 2. And that gallon of milk is just $3.50. That's fine. We just want one of those. And we want 2 packages of this stuff. So we'll make it friendly. Keep it $4. 2 of them is about 8. So I've got an 8, a $3.50, and a 2. So 8, 9, 10, 11, 12, 13. So it is about $13.50, which is less than 15 bucks. So I'm going to agree with her. That's a big hello. A yes, siree. You know what else I say yes to? I say yes to problem number 9. Oh, you're getting a little tired? Little worn out here? That's okay. Yeah. Just press pause. Go play with your puppy. If you don't have a puppy, play with the neighbor's cat, and then come back to work. All right, we're back to work. Let's do this. What are we doing? Subtraction. Okay, we're trying to find out which one works. Did not line them up. No. Did not line them up. No. It has to be this one. It does. Because you have to line up your decimals when you are subtracting. Wouldn't it be terrible if it was like none of them worked? We wouldn't do that. Would we? Let's check. Okay, placeholder 0 minus 9, not enough. So that's going to be a 2 with a 10. 10 minus 1 is 9. Yeah. 3 minus 5, not enough. Got to borrow from the 6. 13 minus 5, 7. Oh, so it really did work. Next one. Okay, same situation. Not lined up, doesn't work. See, the decimal is not even there, which means it's right there. Not lined up. Gotta be this guy. A. Did you pick A? Yes. High five. All right, did you high five me? Okay, I thought so. Ooh, multiplication. Okay, remember we talked about multiplication earlier. For multiplying, you get to ignore the decimal and just deal with the digits. So let's do the digits. I've got a 2 and I've got a 3. 2 times 3 is 6. That's easy, but now I got to deal with the decimals. We got to count the decimal places represented. We got a total of 4 of them. My decimal's right here. I have to move it 4 places. 1, 2, 3, 4. And I'm putting zeros as placeholders. There is my answer. Oh yeah, it's that easy. 2 times 4 is 8. There's an 8 in my answer. Let's count place values. I got 1 there. And when I say place values, I'm just talking about how many that are to the right of the decimal place. There's 1 and there's 1. Like up here, 1, 2, 3, 4. Yeah, I'm counting those. So for the second one, there's 2 decimals right here. So I go 1, 2, and there's my answer. Easy peasy, lemon squeezy. 22 minus 5. I got to do a little margin math on that one. Over on this side. Okay, 2 times 2. Okay, 2 times 5 is 10. 2 times 5 is 10. Okay, 110. 110. Let's count those decimal places. I've got 1 here. That's it, 1. So I got to move my decimal in 1 place. 11. Okay, let's keep going. 8 times 12. Little margin math here. 12 times 8. 8 times 2 is 16. 8 times 1 is 8, plus 1 is 96. So 96 is in my answer. Let's get that decimal in the right spot. There's this place, and there's a place, so I got to move 2 places. There is my answer. Oh, this is so good. 25 times 4. 25 times 4. Oh, that's like 100. 4 25s is so 100. Yeah, I know, right? And then decimal places. Here's 1, and there's none going on over here, so just 1. So 1, it's 10. Yay, 10. Speaking of 10, let's do problem number 12. Yeah, that doesn't make sense, sorry. Subtraction, so I need to make sure I line up the decimals, and I might have to do borrowing. So let's get our borrowing face on. Do you have your borrowing face on? Is it more of a smirk? Is it more of like a smile? Or are you just angry? You got to learn how to borrow, especially if you have brothers and sisters, but they just take stuff. Anyway, let's keep borrowing. So, easy. So 0 minus 7, not enough. I got to borrow. So 3 becomes a 2. I'm bringing 10 over. 10 minus 7 is 3. 2 minus 6, not enough. Got to borrow from the 8. Going to be 7. Now it's 12. 12 minus 6 is 6. 7 minus 4 is 3. Got the 1. And I'm going to just drop the decimal down. 1363. Let's do this next one. Subtraction. My first number is what I have, so it's got to go on top. I'm not going to always put the bigger number on top. That happens to be what's going on here, but someday it's not going to be the case. So for this one, my subtraction, anytime you're subtracting, the first number is what you have, and that has to go on top. And now line up those decimals. 8, 6, 5. Subtraction. Gonna 0 as a placeholder. And looks like, folks, I gotta do some borrowing. 0 minus 5, can't do it. So I got the 4 becomes a 3. 0 becomes a 10. 10 minus 5 is 5. 3 minus 6, nope. 2 becomes a 1. Borrowed. 13 minus 6 is 7. 1 minus 8, nope. Got to do the 0. Wow, this is like some crazy borrowing. 11 minus 8 is 3. And then I just have this 30 left over. And that decimal is just going to fall right into place. Love when that happens. Ooh, another one. Yes. Okay, even though this one has more digits, this number's going on top. Why? Because it's first. It's what I have. So the next one, let's do this. 3, 2, 1. Let's get some zeros as placeholders. And let's go ahead and do some subtraction. 0 minus 1. Nope. Hey, 0, can I borrow from you? Nope, I got nothing. Let me check over here. Hey, 7, you got some to borrow? Yeah, I got some to borrow. So 7 becomes a 6, and this becomes a 10. 0 says, hey, 0, you have some? I do now. 10 becomes a 9, and it's 10. If you listen closely, they really talk like that. 10 minus 1, we got a 9. 9 minus 2 is 7. 6 minus 3 is 3. 0 minus 0 is 0. And my decimal, it's right into place. Nice. That's good. I like this. Multiplying. This is that ignoring thing, right? Yeah, the things you're really great at. Ignoring. So in this situation, it's really good to ignore. Not in some situations. So we're going to take the 58 and the 19, and we're going to multiply them together. And for this one, you can put them whatever order you want. It doesn't matter which one you put on top. It's called the commutative property. 2 times 3 is the same as 3 times 2. So multiplying, you put whatever you want to on the top. I generally just put the bigger one on top. Makes the math a little more something. All right, let's do this one. 8 times 9, 72. 9 times 5 plus the 7 is 52. All right? Yeah. And now this guy right here, this isn't really a 1. It's actually a 10. So I'm going to put a 0 down here because the 1 is in the tens place. So I got to get a 0 down there. Now I'm going to break this one out. So 1 times 8 is 8. 1 times 5 is 5. Let's add these together. 2 plus 0, 2 plus 8, 10. 5 plus 5 plus 1 is 1. Dun dun. Oh, decimal place. I got to get this decimal. So here's 1, and here's 2, total of 3. 1, 2, 3. 1.102. Yeah. 922 times 28. Again, I can put whatever one I want on top, but I usually do the bigger one just because it makes less math at the bottom for it. That's really why. And I kind of like to be a little lazy sometimes. Okay, 8 times 2, 16. 8 times 2 plus 1, 17. 8 times 9, 72 plus 1. 72, 70. Whoa, whoa, easy. Easy. Oh, goodness. Okay, 73. All right. Now, that 2 is not really a 2. It's a 20, because that 2's in the tens place, so that's why I got to put a 0 there. Now, let's go to work here. 2 times 2 is 4. 2 times 2 more 4. 2 times 9 is 18. I'm going to add these up. Now, misconception, something that students do is just make sure you line everything up so you're matching up the place values so it actually works. 6 plus 0 is 6. 7 plus 4, 11, 4. 3, 1 is the 8. 7, 8 is a 5 with the 1. 25,816. That seems a little high. Oh, because I forgot the place values. Let's get those place values. 1, 2, 3. 1, 2, 3. It's right there. 25.816. Yeah. What do we do next? More multiplication? No division. All right. No decimals on these. Okay, we can handle that. 6 goes into 5 0 times. 6 goes into 58 9 times. 9 times 6 is 54. Do we have any remainder? We do. 58 minus 4 is 58 minus 54 is 4. Now drop the 2 down. 6 goes into 42 7 times. And 6 times 7 is 42. It's done. It terminates. Here is my answer. How many 6s are in 582? There are 97 of them. And Christmas colors. I didn't mean to do that. It's kind of fun. How many 11s are in 748? Let's find out. How many 11s are in 7? None. How many 11s are in 74? Well, there's 6 of them. 6 times 11 is 66. Do we have any remainders? We do. 74 minus 66 is 8. Drop the 8 down. There we go. 11 goes into 88 8 times. No remainder. Done. There's the answer. There are 68 11s in 748. Okay, let's keep going. No decimals yet, all right? If there was a decimal here, we'd have to just pop it up in the answer, but there's no decimals. Not very interesting, but we can do this. 7 goes into 2 0 times. 7 goes into 24 3 times. Not exactly, though. 7 times 3 is 21. There's 3 left over. I'm going to drop this 3 down. 7 goes into 3 4 times. Putting the 4 at the top because I'm building my answer. 7 times 4 is 28. Looks like I got a little bit left over here, which is a 5. Drop the 6 down. 7 goes into 56. Exactly 8 times. So it terminates. It's done. How many? If I have 7 in a group and I have 2,436 people, how many groups can I make? I can make a lot of groups. I sure can. Speaking of groups, let's talk about this. Let's talk about fruit salad. 1 cup of fruit salad is 1.4 grams of protein. Everybody loves protein. It makes you feel full. So make sure you get some protein while you're having this. How many grams of protein in this many cups? So I'm not going to subtract it because it's not like a difference thing. I'm not going to add it because that's not going to help me. It's grams of protein to cups of fruit salad, so you wouldn't like add those two together. It's not asking me to split them up, so I'm not dividing. So this is a multiplication problem. So 12.75 times 1.4. Multiplying, I do not need to line up the decimals, but I'm going to deal with those decimals later. All right, 4 times 5. Okay, 20. Right. 7 times 4 plus the 2. I got another one of those. Yeah. 4 times 2 is 8 plus the 3. Okay. 4 times 1 plus the 1 gets me to 5. Yeah. And that 1 right there is not really a 1. It's a 10. So I'm going to put a 0 because that 1's in the tens place. I'm going to do the rest of the math. I'm going to multiply this 1 out. 1 times 5. 1 times 7. 1 times 2. And 1 times 1. Now let's add these up. 0, 5, 8, 5, 6, 7, and 1. 17,850 grams of protein? Holy beans, that's a lot of protein. I think your daily recommended is definitely not that. Oh, oops. Hey, we got to get the decimal places. There's 1, there's 2, there's 3. It's got to move 3 places. 1. Okay, that makes more sense. It's like 17.8. Is that one of my choices? 17.85. Oh, there it is. Ding, 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 ding. Way to go, you're a winner. Speaking of winner, let's be a winner on problem 16. Ooh, multiplication. I'm going to take 136 times 14 and just start with that. 136 times 14. Yeah, let's keep going. I'm surprised I haven't run out of lead yet. It's digital. That's being funny. Okay, 6 times 4. 24. 4 times 3 plus 2. Got the 1. 4 times 1 plus 1. I got my 5. True story. That 1 is not a 1. It's actually in the tens place, so I got to get a 0 down here. Now I'm going to do 1 times 6 is 6. 1 times 3 is 3. 1 times 1 is 1. Let's add these up. I got a 4. I got a 10. 5, 6, 7, 8. I got a 9 and a 1. Let me go check my decimal places. I got 1, 2. I got 3. It's got to move 3 places. 1, 2, 3. So it is 1.904. Yay. 6 students sold books, and they earned this much money. I don't know what kind of books they sold. I wonder how many books they sold. I have no idea, but they must have sold a lot to make $324. Unless maybe they're worth a lot. How much do they each have when they split? Oh, splitting it. Splitting it smells like division. Go ahead, take a whiff. Yeah. I smell division. I do. Division is. I'm going to take that 324.36. I'm going to divide it by 6 people. All right. I have a decimal in there, and that's okay. We got a decimal. I just hope I left enough room. I don't think I did. I got some work. I got to move this out. I got to move this up here. I hate running out of room. Actually, I don't really hate it. I'm fine with it, but I just have to figure it out. Okay, 6 goes into 3 0 times. 6 goes into 32 5 times. 5 times 6 is 30, and I have 2 remainder. Drop down that 4. 6 goes into 24 4 times. Oh, 6 times 4 is 24. My remainder is 0. Now, usually when we remainder 0, we would say stop, but we don't. We have more digits, so I need to keep going, right? 6 goes into 3 0 times. Drop the 6 down. 6 goes into 36, exactly 6 times. All right, got to deal with that decimal. I just need to slide it up into my answer right here. And there it is, 54.06. Totally true. Did I answer the question? Is it reasonable? 6 people sharing $300? Yeah, $54. Very reasonable. Nice. 18, division. Do I ignore the decimals on this one? No, that's still multiplication. First number is what I have, and that is what's going inside the box. 4.3 is out here. Okay, we got to talk about something. We can have decimals in here. Totally acceptable, but we can't have decimals out here. We have to clear them. Not appropriate. No decimals. But we can't just ignore them. We got to deal with them. So let's deal with them. And we're going to deal with them by moving them. Okay, this is going to shift over 1. And whatever I do outside, I got to do inside too. I'm going to shift it over 1, and then I'm going to slide it right up into the answer. So my decimal is now dealt with it. If that's too kind of annoying, hard to keep track of, then you can rewrite your problem. Because it's really 739.6 times 43. That's what my problem changed to. And as long as you change both of them, the answer stays the same. I know. Super cool. It's not magic. It's math. All right, let's start working on this. 43 goes into 7 0 times. 43 goes into 73. I kind of wish it was 2, but it's only 1. Okay. 73 minus 43 is 30. Yep. 2-digit number. Drop the 9 down. I'm going to keep going to work. 40 goes into 309. I have no idea. I'm going to guess. I'm going to look at the 4, and I'm going to look at the 30 and go, I don't know, 4 times 5 is 20, so it's probably more than 5, maybe 6. I'm going to try 6. I'm going to do a little margin math over here. 43 times 6. 6 times 3, 18. 6 times 4, 258. 309 is where I'm getting up to. I think I can do one more 43. So I'm going to add one more 43 on. And I get a 1. Boom. 301. Yep, that did it. Yes. Okay. So how many was it? Okay, so let me look. It was the 6 and then one more, so 7. Don't be afraid to throw a little margin math on there. And do you see what I did? I kind of did some rough estimating to try to figure that thing out. 9 minus 1 is 8, and these rest are gone. Drop that 6 down. How many 43s and 86? There's 2. And you know what I forgot to do? Is I forgot to put my decimal up in my answer early, so I have to deal with it right now. But it's no big deal because I just slide it up into the answer. Ooh, look, more division opportunities. Yes, it's something we need to practice. We get really good at it. Don't avoid these. Yeah. I'm going to go ahead and notice right here, there is no decimal out here, so I don't have to move anything. There's a decimal here, and I'm just going to pop it right up my answer, so I don't have to deal with it later. Let's just keep going. Okay, 4 goes into 9 2 times, which is 8. 1 left over, 1 remainder, drop the 8 down. Okay, 4 goes into 18 4 times, right? 4 times 4 is 16. I've got me a remainder of 2. Drop the 6 down. 4 goes into... Oh, it doesn't end. This keeps going. Okay, 4 goes into 26. The closest I can get is... Make maybe 6. 4 times 6. Yeah, 4 times 6 is 24. It's going to get me nice and close. I still have a remainder of 2. All right, I ran out of digits, but remember, we can add zeros on the end, and it doesn't change the value of this. And now I can drop it down into place. 4 goes into 25 times. My decimal terminates, and there is my answer. Let's do the next one. All right, so I have 4.25 divided by 3. No decimal out here, so we can leave it alone. We're all good. I'm going to put my decimal up in my answer, and then I'm going to keep solving. Considering that last one we did, we're probably going to have to add zeros on this thing. 3 goes into 4 once. 1 remainder. Drop the 4 down. 3 goes into 14 4 times, which is 12. So 12 minus 12. And I got me a 2 remainder. Drop the 2 down. 3 goes into 22 like 6 times. Yeah, that's 18. Oh, 7 times is 21. Yeah, 21. That's as close as we get. With 1 remainder, drop the 5 down. 3 goes into 15. 5 times. Terminated. We didn't have to add any zeros. Neener. Okay, we got this last one. 206 divided by 5. Again, no decimal out here, so we don't need to move any decimals. Let's do this. 5 goes in... Oh, I'm going to put my decimal up here. Done. 5 goes into 2, 0 times. 5 goes into 20, 4 times. No remainder. Drop the 6 down. 5 goes into 6 once. 5 times 1 is 5. We got a remainder. Oh, we got a 0 situation. But we didn't have to go very far. 5 goes into 10 2 times. And there is my answer. Did we do it? Oh, found more problems. Does this review ever end? Holy beans. All right. 250 divided by 0.1. Okay, we got a decimal in here. We got to deal with it. All right. Again, we can have decimals here. Cannot have decimals out here. I'm going to move it one place. My decimal's right here, so I got to move it one place right here. Get a decimal placeholder. I'm going to slide it up in my answer. Now I can start chipping away at this. 1 goes into 2 twice. 5. Oh, there it is. That's my answer. 2,500. Oh, yeah, because if I have 250 and I'm dividing it by a really small number, it's going to be a pretty big number, which is what it is. 25 divided by 1, that's so 25. 2.5 divided by 1. Oh, that's still 2 point. Anytime you have something divided by 1 is it itself. Let's look at this guy. Now, this number is on the outside. Let's take a look. 2.5 divided by 0.1. So I can't remember. I can't have a decimal here. So I have to move the decimal. 1, so move the decimal. So this is 25 times 1 again. This also equals 25. There's a whole lot of 25s going on here. How about this guy? That's an arrow. It's a terrible arrow, but it's terrible. Oh, I'm making it worse. I should just stop. So 2,500 divided by 100. Okay. How many 100s are in 250? There are 2 of them. How many 100s in 500? There's 20. What? Yeah, totally true. This also equals 25. Might you make you wonder if that's 25? I don't know. Let's see. Maybe it's not. Oh, if I move the decimal, look at this. 2 places on this one and 2 places on this one, it becomes 25 divided by 1, which equals 25. Okay. What we were practicing on that one, just to let you know a little bit, is just, are you keeping track of your decimal placement? That's really what it is. Like, can you see where your decimal is supposed to be in your answer? Problem number 21? Yeah, we've been doing a ton here. I need a nap. But let's finish. I think this is the last one. It is! Whoa, the answers are here? Oh, who put the answers there? Yeah, I did. All right, let's do this. 1.6.5 divided by 3. 3 goes in 1 0 times. 3 goes into 10. 3 times. 3 times 3 is 9. Let's subtract. I got 1 left over. Drop the 6 down. 3 goes into 16 5 times. Because 3 times 5 is 15. I got 1 remainder. Drop the 5 down. 3 goes into 15 5 times. Yeah, 5 times, and it's done. And my decimal is right there, 35.5. That wasn't so bad. What else we got here? We got a 58.8 divided by, oh, I see it, 0.7. See that? Yeah, you see that. You don't see it? You see it right there. Doop-a-doop-a-doop. Uh-oh. We got to clear that decimal. We'll move this one, so I got to move this one. Decimal's a new home. Put up my answer. Now, let's divide. 7 goes into 5 0 times. 7 goes into 58, like... Oh, 7 times 8 is 56. That's pretty close. 58 minus 56 is 2. Drop the 8 down. How many 7s are in 28? There are 4 of them, with no remainder. There is my answer. All right, one more. One more finale. Don't stop. Keep going. Don't give up. Let's do it. And look at it. It's a fun one. We have we got to clear the decimal. Now, sometimes the decimal doesn't clear all the way out. It seems like on all these, they have been clearing all the way to the end, but that's not the case. That doesn't always have to happen. Maybe the decimal's here and it moves like 1 place, and it's just in the middle of the problem. That is a thing. All right, so I have 11. I'm going to rewrite my problem. You don't have to if you don't want to, if you can keep track of it. I'm going to just do it so I can keep track of it. 11 goes into 2 0 times. 11 goes into 25 2 times. 11 times 2 is 22. Subtract that out, and I get, what is that, like a 3? Yeah, and drop the 7 down. 11 goes into 37 3 times. 3 times 11 is 33. 37 minus 33 is a 4. Drop the 4. 11 goes into 44. A nice 4 times with no remainder. We have a termination. Doo-doo-doo. Are we all done? We did it. Oh, good job. I am super proud of you. In fact, I am so proud of myself and you all that I am going to go buy some ice cream and feed the neighbor's dog ice cream. Because actually, I don't really care for ice cream too much. So I'll just feed the neighbor's dog and see what happens. That could be interesting, right? Maybe. All right. I hope